All right, so we're going to continue on with some more slope fields. We're going to do the rest of this section 7.3.4. Look at this guy. Right there. We're going to do 7-140. So first thing we're going to do is we're going to solve these differential equations. So the first one, I'm going to rewrite f prime of x as dy dx, because that's what that means. The derivative of something is e to the x. Well, you should know that the derivative of e to the x is e to the x, but we're going to go ahead and show that through our differentiation tools. Let's move the dx to the other side. We're going to integrate, and if I integrate dy, that's like saying 1 dy. The antiderivative of 1 is y with respect to y, and the antiderivative of e to the x is e to the x. All right, so that is going to be our first one. Let's do our second one. The derivative of some function is 2. So let's move the dx to the other side. We're going to integrate. Once again, this becomes 1. What is the antiderivative of 2? Oh, this is going to be y equals. The antiderivative of 2 is 2x plus c. And the last one is the antiderivative, or the derivative of something, is x to the 2/3. So we're going to move the dx to the other side. Take the antiderivative of y, antiderivative of x to the 2/3. So what is the antiderivative of x to the 2/3? Well, we're going to add a power to this, so we'll get a total of 5/3. And if I was to take the derivative of 5/3, how would I get a coefficient of 1? Well, if I'm going to bring 5/3 down here, it needs to multiply by the reciprocal, which is 3/5. So 3/5 times 5/3 makes a coefficient of 1. We'll say plus c. So the next part here, it says there are 3 slope fields for the differential equations that we just did. We want to figure out which slope field matches the differential equations that we solved above. So why don't you go ahead and figure out which one matches which just by looking at their slopes. And then, so pause the video and then I'll go through it. Okay, so I'm going to assume that you tried it, and we're going to go ahead and do the first one here. So which of these graphs looks like e to the x? So if I took the derivative, because it's e to the x plus c, so it's all of these different ones, where they're all going to be parallel to each other, and they're all going to have an exponential equation. So which of these looks like an exponential equation? It's going to be this one. So let's say this is e to the x plus c, and if I was to say what is one of the equations that fits this, it'll look something like that. And all of these will look like e to the x plus c in that order. All right, so the next one we have is 2x, and that is going to be this one here. So this is going to be 2x plus c. Or we could have written that the original equation was 2, and then we could have written this one was, the original one was e to the x. And one of our slopes, or if it went through 0, I suppose, would look something like that. That would be our 2x. And then that means that our last one is going to be 3/5 x to the 5/3. Or our original equation is x to the 2/3. And our graph would look something like, nope, maybe something like that. There we go. Okay, and you're going to practice that in our one homework problem that I'm going to give you. 143. Very challenging. I will see you guys later, and